Good morning, everyone. I am Teacher Renzo and I am your science subject teacher. Today, we're going to discuss about the electromagnetic spectrum. But before we proceed that, I just want to say a happy synchronous day. And before we proceed to our discussion, I have a short video that I prepared for you. And let's watch this.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at the electromagnetic spectrum. What we see as light is only a small part of the electromagnetic spectrum. The electromagnetic spectrum refers to the many types of radiation released from stars, including our own sun. Electromagnetic radiation travels in waves. Frequency describes how many waves per second a wavelength produces. Wavelength measures the length of an individual wave in meters. Scientists describe the electromagnetic spectrum as a long line. At one end lie radio waves, with the longest wavelengths and lowest frequencies in the spectrum. A single radio wave has the length of a football field. After radio waves come microwaves, which produce more energy due to shorter wavelengths and higher frequencies. Cell phones, radar, and microwave ovens use microwaves. Next comes infrared light. The sun, fire, living creatures, and other heat sources all produce infrared light. While we cannot see infrared light, we feel it as heat. Visible light occupies a narrow slice of the electromagnetic spectrum, nestled between infrared and ultraviolet light. Red wavelengths have the lowest frequencies and longest wavelengths of visible light. As you move from red through orange, yellow, green, blue, and finally violet, wavelengths shorten and frequencies increase. From visible violet light, we move into ultraviolet frequencies. Human skin produces vitamin D when exposed to ultraviolet light, but excessive ultraviolet light causes sunburns. Next, X-rays, which pass through soft tissue but not in denser materials such as bone, making them valuable for medical tests. X-rays also have security applications such as airport baggage checks. Gamma rays produce even shorter wavelengths, higher frequencies, and more energy. In comparison to the football field-sized wavelengths of radio waves, gamma ray wavelengths are as small as atom nuclei.
For thousands of how-to and advice videos on any topic, visit monkeyc.com.
Okay, let us proceed to our discussion. Let us discuss about the electromagnetic spectrum. Okay, to further explanation, the electromagnetic spectrum, we need to be guided by the following concepts. And what are those concepts? Number one, each part of electromagnetic spectrum has a specific wavelength and frequency. Frequency is inversely proportional to the wavelength. Number three, these waves have various applications in our daily lives. First, radio wave has the longest wavelength but lowest frequency. Their wavelengths range from 1,000ths of a meter to 0.001 meter. The second part is microwaves, are a part of radio wave, but their wavelengths are shorter than radio wave. Third one, infrared wave or heat waves have shorter wavelengths compared to the radio wave. Their wavelength measures 0.001 meter to 700 nanometer, shorter waves than radio wave. 4. Visible light is the only band or part of the electromagnetic spectrum that can be seen by our eyes. The wavelength of this visible light ranges from 700 nanometer, or called the color red, to 400 nanometer, which is the violet color. The fifth, or the next part. Ultraviolet rays are not visible to the human eye, but certain insects like bees, butterflies, can see this type of wave. UV rays have wavelength but about 400 nanometer to 10 nanometer and have a higher frequencies compared to visible light. This means they can cause more damage to human cell. It causes sunburn to our skin. X-rays are waves that have enough energy to penetrate tissue but can easily be stopped by dense material like bones. They have wavelength ranging from 10 nanometer to 0.001 nanometer. X-ray detect bones and some baggages when it comes when we use X-rays in the port or airport. Gamma rays are the waves the shortest wavelengths that measure from 1 trillionth of a meter to 10 raised to the power of negative 12 meter. This means they have the highest frequencies. Thus, gamma rays carry the most energy. We have a question here. What is the speed of each of the electromagnetic wave? The answer is all electromagnetic waves travel at the speeds of light 186,000 miles or 300 million meters per second in a vacuum. The next question is what happened to the frequency of the wave as the wavelength decreases? The answer is the frequency increases as the wavelength decreases. The third question is, what have observed about the relationship of wavelength and frequency? The answer is the relationship between the frequency and the wavelength is an inverse relationship. When one increases, the other is decreases. Let's elaborate. X-ray and radio waves. Why are X-rays more harmful to us than radio waves? Long-wavelength radiation such as radio waves transmit less energy compared to those bands that have shorter wavelengths. As we can recall, the longer the wavelength, the lesser the energy produced. Since radio waves have the longest wavelength, they have the lowest energy produced. This is why X-rays are generally more harmful than radio waves. X-rays pack more punch of energy because of their shorter wavelengths. Thus, they can penetrate deep in the human body and even right into our cells. For the same reason, gamma rays are the most dangerous bands of the electromagnetic spectrum. And that's all about electromagnetic wave. And that's all for our discussion. Thank you, God bless, and I hope you understand what is electromagnetic